Hey, it's Dr. Brad with an amazing result brought to you by some of my colleagues here at ANU in Canberra, led by Lex Van Loon, about how safe it's going to be for astronauts to go to Mars. Because we've had this huge question, and when astronauts get there and step off their spacecraft, are they going to faint? Believe it or not, lots of astronauts returning to Earth do faint. So when you're in space, you actually get lots of extra blood pumping to your brain. And that's actually because there's no gravity to pull all that blood down, something we're used to. So when we see astronauts in space, we see their hair floating around, but we also see with strained heads, they have a little bit of red faces. In fact, their heads get a little bit bigger. Now, when those astronauts come back down to Earth, now all of a sudden we have gravity, and gravity pulls and drains all of that blood down to their legs and feet. And so when you look at astronauts returning from space, often they're sitting. They also look quite sickly white. They almost look like they're going to faint because they feel sick and queasy. Now all of a sudden that blood is coming from their brain. And there have been very well-documented incidences in the early days when astronauts would go up and they would just faint because their body hasn't adapted to the way gravity's moving blood in their body. So this really cool new result has now shown that it's actually going to be safe for astronauts when they get to Mars. How? Obviously, we haven't sent people there. Well, they've used computer modeling, where they've taken the way fluids and blood move in the human body, and were able to accurately model how that happens on Earth. They were then able to take that same program and change the effects of gravity. You can take the effects of gravity way down, i.e. microgravity in space, and see what happens. And we know that result. But the trick and the key result here is what happens to Mars. Mars has about a third the gravity of Earth. So they're able to dial up the gravity a little bit more than in space, but a lot less than on Earth, and see what happens. And as it turns out, it shows that the blood flow is actually okay, that when the astronauts would step off their spacecraft, they wouldn't have this huge rush of blood going down to their legs, feeling faint, and therefore falling over, but they would have kind of somewhere in between, meaning that, they probably won't feel the best, but they won't faint and likely injure themselves. So we can kind of think of this model of the human body a lot like water in a building. Imagine we have water at the ground floor and we have to pump it up to the 10th floor, i.e. gravity on Earth. So you build your system so that the water can get all the way to the top. There's enough pressure through the tubes to send that water so when you turn your tap on, you get water. Now, we also know, because if the pump can get it to the 10th floor, it also works on the ground floor. How does it work getting to the 3rd floor? And more importantly, if you change your pump for it only working on the ground floor, getting water around, does it have enough oomph to get to the 3rd floor? This is essentially our human body. Our human body has a pump, the heart, blood, the liquid, arteries that are the tubes. And in space, we have the ground floor where there's no gravity. On Earth, we have the 10th floor where there's lots of gravity. And then Mars, the 3rd floor, where there's some gravity. And what we've now known for a long time is that when the human body gets used to working in space, our heart becomes a little bit lazy. So when it comes back down to the ground, it can no longer pump that blood to the 10th floor, i.e. Earth. But could it pump blood to the 3rd floor still? That is the big question. Could you have enough oomph to get your blood to the brain on that 3rd floor level, a third the Earth's gravity, and still work? And it turns out, yes, the human body will be fine, for the most part, in terms of blood stepping off your spacecraft when you get to Mars. But why are we worried at all of astronauts falling on Mars? Well, there's actually a lot of health problems and issues associated with it. Firstly, we've actually known from some recent data that astronauts' bones weaken in space. They lose density in their bones, so their bones become a little bit more brittle. And you can imagine if you faint on Mars, the risk of breaking a bone, a hip, an arm, a leg is quite severe. And herein lies the really big problem. Mars is far away. I'm sure you understand Mars is far away. But there's actually a big issue with that. Mars is so far away that it takes time to send a signal back to Earth. Because of the orbits of Mars, sometimes Mars can be somewhat close to the Earth and only take about 8 to 10 minutes to send a signal to Earth. Sometimes, kind of like cars around a racetrack, Mars is on the other side of the sun to Earth, and so it could take a really long time, 20, almost 25 minutes to send a signal to Earth. So if you have an astronaut and they get hurt or injured, and you have to call Earth for help, you don't want to be waiting an hour for that signal to get to Earth and then them to reply the 25 minutes to come back. And then you also just have this huge problem of remoteness. Astronauts are going to be spending a long time getting and in Mars. So because of these orbits of Mars and Earth, again, kind of cars going around a racetrack, sometimes Earth and Mars are close and sometimes we're far apart. On the close points, it takes about 6 months to get to Earth from Mars. But by the time you've made your journey to Mars, Earth has gone around the sun. So you actually then have to wait on Mars for then Mars and Earth to come back close together again, so that it's only a 6-month trip back from Mars to Earth. This means actually for the trip to Mars, staying on Mars and come back to Earth, it will be a couple of years. And you can't launch all the time. You have to wait for these 6-month windows, as we say, and this happens about every 25 months. So if someone gets sick on Mars, you can't just say, send them back to Earth. You have to wait for those orbits to align. And this becomes a really big challenge, not just them falling over and getting injured, but what if they just get sick? You're going to be spending 1.5 years, 2 years on this whole journey getting to Mars and back. Just think of, taking any group of humans and locking them away for 2 years. Eventually, something's going to have an illness, maybe not a cold, but a problem with their stomach or bones or something. We have illnesses, we get injuries, that happens. But you can't send them back to Earth. And this is very different from the International Space Station. On the International Space Station, if something goes wrong, they actually do have the option. And in some cases, they have sent astronauts from space back to Earth in emergency situations. That is not the case with Mars. You cannot send them back safely. So whatever happens is they need to be able to solve these medical issues on Mars. So therefore, someone breaking a bone on Mars can actually be a really critical medical problem as compared to anywhere else near Earth. That's actually just a small fraction of the problems. So, this study is kind of saying, all right, they may not faint, but that doesn't mean astronauts are going to be safe. There's a lot of other problems. Obviously, radiation comes to mind. We know radiation is bad, and being exposed to higher levels of radiation can lead to higher rates or higher risk of cancer. And we know on the trip to Mars, they're going to have a substantial amount more exposure to radiation. Both the trip to Mars and on Mars itself. Mars actually gets a lot more radiation on the surface than Earth does due to the lack of a magnetic field or a weaker magnetic field, this protective bubble from radiation that keeps us safe here on Earth. Mars doesn't have it. So it's not going to necessarily be a problem when they get to Mars, but as those astronauts get to Mars and come back, it may create long-term health problems. We also have issues with vision. It is well documented that International Space Station astronauts, when they spend 6 months or so in the International Space Station, have changes to their eye. They actually have changes in their vision. And these are often people historically in the past who have been pilots and have perfect vision their entire life, and now all of a sudden they're having vision problems. It's believed to be due to some pressure in the brain, due to some of those effects that we talked about earlier. So what's going to happen when those astronauts get to Mars? Are they going to have vision problems? Will it stay within their entire trip? Will they get it changed back? Will it get worse on that trip? And they're also going to be spending a lot longer than what we've been doing these tests for. A lot of the astronauts in the space station spend 6 months. As we just talked about, these astronauts are going to take about 2 years to leave Earth, get to Mars, stay there, and come back. But there's also other kind of random things. Dust. We kind of know that here on Earth, dust can irritate our eyes, it can irritate our skin. If you have very specific types of dust or things, silicosis, for instance, if you breathe in a lot of this stuff, you can get effects in your lungs. Well, Martian dust is very different, very fine than the dust here on Earth. What if you get it all over you and your capsule? You can't just get the broom and sweep it out easily. So how will the dust affect your lungs, eyes, skin, and other cases? And this is just a sample of the many issues that teams all around the world, including the team here in Australia who's made this discovery, are trying to solve to make space travel to Mars a lot safer. I hope you enjoyed this video about this awesome result. Stay tuned and subscribe on YouTube to stay up to date about more exciting results from the space world.